Okay, so the first step is just to come to github.com, Lucian Marin pybench, and in this repository, as we can see, is very simple, but the idea is to use the standard library of Python 3.1, and to install it, we just execute the pip install requirements, and to execute is just with the pybench command. If we look at the requirements, we can see that it only uses dqdm. So yeah, and to clone it, we just come to this section and we just copy this URL. So that's exactly what I did. Now for the platforms that I'm gonna be testing, it's gonna be Windows, Mac OS, Linux, and an iPad Pro. All of the Windows are running on the same machine, it's just a different environment. It's a machine with 16 gigs of RAM, Ryzen 3700X, and an NVIDIA RTX 3070, but that doesn't really matter for this test. Yeah, so the platforms that are gonna be is Windows native, so basically just the standard Python 3 installation. Windows Conda is just the Python that comes in Conda, is Python 3.8. Windows WSL2, this is like the kind of virtualized Linux that runs under Windows with its own kernel. MacBook Air with the M1 processor, Linux with an Intel 8750H, and an iPad Pro that is running under ISH. And this is also like an emulated environment inside of an iPad, just for perspective. I executed neofetch in each of these environments, so a little bit of details will be shown regarding each one of them. So the first one is the Windows native, and this is running again with the 3700X with the 16 gigs of RAM. Now we have the Conda environment run under the same system, and here we can see WSL2, same system, and now Linux. This is running under PopOs. This is a variant of Ubuntu, and this one is running in an Intel 8750H laptop with 32 gigs of RAM. And here it is the MacBook Air with the M1 processor and 8 gigs of RAM. So actually, like, nothing fancy in each one of these systems. And well, finally the iPad Pro on the ISH environment. That again is just like a virtual machine inside of the iPad. Here I'm running from top to bottom Windows native, Windows Conda, Linux using the Intel, and the Windows under the WSL2. First, it will execute the calculation of P iteratively, so it will go like from the very beginning until it reaches the end. Then it calculates a very long Fibonacci sequence recursively, and finally the same Fibonacci sequence iteratively. And in this case, each one of these is like very similar, but at the end the rate just changes, especially on the recursively. And here you can see how it runs in the MacBook Air with the M1 processor and the iPad. Interestingly, the iPad, because it's running in the ISH environment, which is kind of like a virtual machine, is way slower, and the estimates are like way off, like over 30 minutes. I will not wait all the time. It's just like an interesting example of what can be done in the iPad. And here are the final results. On the top right is the table with the results for each one of the tests, and on the bottom left is the chart. It's just a representation of the data from the table. The overall faster was the Windows under WSL2, which is really impressive taking into consideration that it's not fully native, but indeed Microsoft did good here. The second fastest was the MacBook Air with the M1 chip, which talks great about this platform. And the slowest of the bunch was the Linux under the Intel processor. To be fair, the slowest of the processor of the bunch, so it's not that surprising either. Still, the difference wasn't too big between them, and maybe with longest test, or maybe just stressing a little bit more the RAM, different conclusions could be driven. The iPad basically just, it didn't finish. It's just way too long to wait, and the graph would just look awful also. And that's it. Thank you for watching, and if you want to see something else or more details regarding this, just comment below. Bye.